Lesson 1-4, the distributive property. In this video, you will learn to express the distributive property to evaluate expressions and use the distributive property to simplify expressions. So in this section, your vocabulary are like terms, simplest form, and coefficient. Okay, so the distributive property, it says for any numbers A, B, and C, A times the whole quantity of B plus C is the same thing as A times B plus A times C. So that's like you take the A and you multiply it to both the B and the C, and you leave the plus in between it to get this. Okay, it also works backwards. You can have the A outside the parentheses, but on the other side, and still A times B and A times C. Or B times A and C times A. Okay, and that works with numbers too. So if we're following order of operations here, 2 plus 5 is 7, times 3 would give you the 21. But it also works if we do 3 times 2 plus 3 times 5. So 3 times 2 is 6, and 3 times 5 is 15. 6 plus 15 is also 21. So it works either way. Okay, so we want to distribute over addition. So this problem says Julio walks 5 days a week. He walks at a fast rate for 7 minutes and cools down for 2 minutes. Use the distributive property to write and evaluate an expression that determines the total number of minutes Julio walks. So here, just because we're looking for the total number of minutes, each day he does 7 minutes fast, and then he does 2 minutes of cool down. So we can say basically that every day he does 9 minutes. And he does that 5 days a week. So we take the number of minutes per day times 5. So we can solve this and say that this would be the same thing as 5 times 9 and get 45. Or we can use the distributive property and say this is the same thing as 5 times 7 plus 5 times 2. So we take that 5 and we distribute it to both the 7 and the 2. So 5 times 7 is 35. And 5 times 2 is 10, so we still get 45. Either way we do it. Okay, you guys do this one. Okay, example 2. Use the distributive property to write 12 times 82 and then evaluate. So now here, what we can do is use the distributive property to rewrite this so that it would be easier to solve, because right now if you have 12 times 82, you probably have to do multiplication by setting it up and do 82 times 12 and then go through 12 2 times everything and then 1 times everything and then add, if you guys remember, multiplication. Or you can put it in a calculator, but let's say you don't have a calculator. We want to know a way that you can possibly simplify this so that's a little bit easier. So instead of going through that process, what we can do is look at our two numbers and see if there's an easy way we can write this that would be easier to multiply. Now, if I think of 12, 12 is the same thing as 10 plus 2. Generally, numbers are really easy to multiply by 10 because you just add a 0. And 2 is pretty easy too because you just double it. So I'm going to rewrite this as 10 plus 2 instead of 12 times 82. And now we can use the distributive property here and multiply each of these numbers by 82. So we have 10 times 82 and 2 times 82. And it's still plus in between them. So 10 times 82 is 100, it is 820, right? And then 2 times 82 is going to be 164. So now I can just add these two numbers. 4 and 0 is 4, 6 and 2 is 8, and 1 and 8 is 9. So 984, which is the same thing I would get if I had multiplied this over here, but it just could be a lot faster to think about it mentally and break it up using the distributive property. Okay, so you guys try this one and think about how you would break this up so that it's easy to multiply. Okay. Rewrite this using the distributive property and then simplify. So using the distributive property, I'm going to do this times that and that times that. So 12 times y is 12y. And 12 times 3 is 36. And I leave it like that. Now it says to simplify. but I don't have any terms that are like alike. This is y, and this doesn't have a variable. So this is as simplified as it goes. For b, I'm going to use the same thing, except when I have 4, the 4 in front, when I have 3 terms, the 4 in front still applies to each of them. So 4 times y squared is 4y squared. 4 times 8y, 4 times 8 is 32, and I still have a y. And we should just go back to it. Okay, and 4 times 2 is 8. So all of these get added together, and there are no like terms. This one's y squared, this one's y, and this doesn't have anything. So this is as simplified as we go, and we're done. Okay, you guys simplify this using the distributive property. What is that equal to? Okay, if I have something like this, where I have like terms, so this one here, it has an a, and this one has an a, and they have no other variables, and they have the same power of technically 1. So once you have that case, they're called like terms. You can combine them. So this would be the same thing. If I have 17 a's here and 21 a's here, how many total a's do I have? I have a total of 38 a's. So you just add the coefficients, so the numbers in front of a letter are called coefficients. So if I have the same letters on both of them with the same powers, I can add the coefficients to get the new coefficient of 38 in this case. Okay, so here I want to see which ones are like terms. I have b squared and b squared here, and here I have b. So because these two are the same, I can combine them. This one is different. I can't mix it with them. So I have 12 and negative 8. 12 minus 8, I have 4b squared. And this doesn't have anything to combine it with, so I just leave it as 6b. I can't mix them because this one is a squared, and this one's technically to the first. Okay, you guys do these. Okay, example 5. Use the expression 6 times the sum of x and y increased by 4 times the difference of 5x and y. So we want to write this using what we were doing. So 6 times the sum of x and y. So 6 times the sum of x and y. So when they say that sum of x and y, it groups them together, and then it's 6 times that whole thing. Increased by 4 times the difference of 5x and y. So the difference, again, this is grouping this part here and then multiplying by 4. So it's going to be 5x minus y. Difference means subtraction. Okay, so write the algebraic expression in a verb for the verbal expression. We just did that. Now the next part is to simplify the expression and indicate the properties used. So I'm going to come back to this slide here and do it here. So first thing I'm going to use is the distributive property because I have these parentheses. I can't simplify inside of the parentheses because they're your variables. I don't know what they are. So I'm going to simplify it by using distributive property. So I do 6 times the x first and 6 times the y. And then over here, I'm doing the same thing with this one. I'm doing 4 times 5x, so I get 20x. And 4 times negative y, careful with the negative, it's going to be minus 4y. Okay, and this is the distributive property. Okay, and then from here, I want to combine like terms. So this is an x, this is a y, this is an x, and this is a y. So I want to combine the ones that are the same. So x and x's together. 6x and 20x gives me a total of 26 x's. And then here, and this, I have a total of 2 y's. So I can simplify like that. Okay, you guys try this one. Okay, so just to review some of the main properties that we've learned before in this chapter so far is the commutative property, which says you can switch the order that you add or multiply and it doesn't change it. The next is the associative. That's when we move the order, the parentheses, within a set of three things. And then we have the identities. It's for addition. It's 0. If you add 0 to any number, it stays the same. 1, if you multiply any number by 1, it stays the same. So the identities are what number you add or multiply that keeps it the same. Okay? There is no 0 property for addition, but the multiplication, any number times 0 is 0. The distributive we just learned today. And substitution, if A equals B, then A may be substituted for B. So we can replace something if they're equal. Okay, and that's the end of the lesson for tonight.